short tutorial on the Hwi&Swi Tirtos, and we're going to see about the interrupts. The first thing we're going to see is about the hardware interrupts. So I'm actually going to enable my, the hardware interrupt.c file and the configuration file. And as you can see here, you can see that we have the header files, and we have an initialization of the hardware and the toggle. And in the hardware initialization, what we do is also we set up a timer, and we enable the interrupt for a 500 millisecond, and it's basically a periodic timer. And in the LED function, you can see that we clear the flag, toggle, and we print out the values, the number of times it toggles. And now we are going to actually introduce a function that's going to be a hardware interrupt. So what we do here is, we come here, just go to logging, and make add logging setup, and then also for execution analysis, the task, as well as the hardware interrupts are enabled, CPU load is enabled, runtime control logging, etc. is enabled. And going back to our kernel, in the threads we enable the hardware interrupt, and we enable the HW high, go to instances, create one, which is this is from the data sheet. It's actually the handle is timer underscore 2a underscore int, and we want to basically execute that function every time the interrupt happen, and that's the interrupt number, so which is 39. That can be found in the data sheet. And so we give a priority which is -1, which is the highest for the function. So once this is created, so pretty much what we can do is build a project, and so until that time, as it builds, let's look a second example, which is the toggle on software interrupt. And that function, as you can see, it's pretty much the same, but now we have timer ISR, which is again nothing but posting software interrupt handle. So that's software interrupt handle. And again, in your initialization, we're going to initialize your GPIOs and your timer, and going to your software interrupt. Since you also have a hardware interrupt, you can also enable that. And on top of it, so you have your logging function, execution analysis, and the rest of them are okay. And then you go to your function over here, and you can see you have both hardware and software. So the hardware is again at this created instance, which is now the function that we want to execute every time is the timer ISR function. And that timer ISR function is the one that basically is going to give you the software interrupt. So you go to the software interrupt, and again add the interrupt. That's the number of priorities which are given, and again over here, let's say you want to say on software interrupt, when that particular handle is generated, you want to toggle the LED. Let's make the interrupt this. Let's check if our previous one has been completed. It looks like our previous one has been completed on the hardware interrupt. So what we're going to do is hit our execute button. Let's get rid of that. And so you can do the regular stuff, come back here. That's the hardware interrupt you can see in your object viewer. That's the timer 2 object viewer. And yeah, so pretty much we don't have a task or the software interrupt. Okay, so it's only idle. So what we're going to do is let it to run. You can see the LED is blinking. Okay, so let it to run for about 5 to 10 blinks. Pause it and go to the tools, go to the analysis, execution analysis, and we're going to get the CPU load. Say OK, that's your live session, and you can see in this case, yeah, so all the details of your hardware. You can see that that's where the hardware interrupts are happening. Come to the execution, and there you go. So you can actually see this is your actual normal function, and if we are kind of zooming into that function, there you go. So you can see that this is your, actually this is saying unknown, but in your case you probably should see that's an idle function. That's where the start of the hardware interrupt happens, and that's when the hardware interrupt ends, and then that's so this is where the function toggle LED takes place. Okay, so this is your execution graph, and if let's do the LED toggle software interrupt. So I'm going to actually exclude these builds now, and let me include these builds. Okay, so we made some changes, so we're going to compile it. Let's rebuild it. Wait for it to compile. So one thing in this you might actually find a little bit strange is that your execution graphs, because you have two context switching, and the memory in your debugger in your T+C might not be enough to hold all these different data points, and so yeah, that's our compilation, and we're gonna hit it too. So now we can see the LED blinking, and let it run for some time so that the debugger can actually log some data or collect some data. So pause it, and let's go to the objects. There you go. Now you can see that's a software interrupt that's there, which is now the one that is doing the toggle LED. If you go to the hardware interrupt, that's your hardware interrupt that happens, which is triggering the timer ISR. So as you know, the hardware interrupt triggers the timer ISR, which is then trying to generate the post, which is the software SWI handle and then triggers the toggle LED. Okay, so so now we have this value. So let me look at our execution analysis if we can get any luck, because I've tried this before and I don't think I had any luck on this. Says the execution graph is good. Here is my data. There you go. And you can see that's basically the LED is toggling. That's the data that is recorded, but there's no recording of the software. And okay, so that's there. Execution, yeah. So there seems to be some problem in finding out the execution graph, and obviously the CPU load. But the program works, but still the execution graph doesn't turn out. Okay, thank you.